Bridges today are very expensive to maintain. Rust, salt air, ice, freezing conditions change the structural characteristics. Whereas in the future, when bridges are made of materials that can resist the elements and require minimum maintenance, maximum safety, designed of much lighter, much stronger materials to resist high winds, earthquakes, and most all the known forces against bridges, they will be much more efficient than they are today. Bridges of the future will be fabricated in a very simple manner, and they'll be brought to site by floating twin-hulled cranes and positioned and erected automatically without the use of manpower at all. This bridge configuration is comprised of a central member with cables that support the entire bridge. It can be made of prefabricated elements and brought to the site and then assembled automatically and interlocked, forming a complete transportation system. This bridge is a covered bridge. Beneath the bridge hangs a maglev train, which is suspended beneath the bridge not to occupy space on the bridge or interfere with traffic. It also gives the passengers a better view. Wherever there's drought, wherever there's land that is fertile, that has less water than needed, we will build canals, waterways, pipelines to supply water for irrigation, recreation, home use, and any other purpose. These canals extend into the surrounding water, the oceans that surround, say, Africa. The salt water is then introduced into these canals because they are at a sufficient level to bring in the salt water. This unit, this mega machine, is capable of varying its shape so that it can produce any contoured canal system desired. In other words, if we need a canal of a certain depth, a certain degree of slope on the walls, this unit here can vary its shape to accommodate those needs. As the machine moves along, it shapes the bottom by means of lasers, high-energy laser systems. The laser beams sweep the ground beneath it and melt it as it moves along, also shaping it to the optimal contours for a particular canal. It's one of the large megaforming and terraforming machines of the future. Then the canals are flooded with water, salt water from the oceans. This machine then moves along and lowers the glass unit onto the canal borders. Then by thermoelectric means, we will cool the surface. And since the temperature is much colder than the water, and the water begins to evaporate upward and condense as moisture does on a cold glass. You take a glass out of the refrigerator, the moisture condenses on it. Evaporative condensation is similar to that. The moisture that condenses on the inside flows to the side and terminates in a trough. And that water is then pumped to various regions that require its use. We can build these units a mile long over saltwater canals and get all the water we need by evaporative condensation. We can make water available to regions formerly immersed in drought, where they could not grow anything. This way we can build hydroponic agricultural systems, develop new lands for growing all kinds of food and plants. We would have the water available. They're also used for flood control, transportation of bulk freight, transportation of huge prefabricated sections of a building. They are carried on a barge, and then they're slipped off the side and put in position. Some of them are production centers, some of them are chemistry labs, some of them are general research on desert materials and resources, but the whole system is delivered with built-in electrical, furnishings, equipment, electronics. So instead of putting up buildings, delivering building materials to the area, having waste and scrap, they're all fabricated at massive construction places. And on the side of the building, we have a built-in transport unit that can transport people to any building, and they'll be extended for miles. The Sahara Desert today, mostly goods are transported by aircraft or caravans, very primitive method. If you build highways on the Sahara Desert, there are many windstorms. It's very difficult to maintain them, and it's very difficult to keep traffic free of sand. To facilitate transportation in the Sahara, we will build units of this kind, which are about 40 feet below the desert level. Now, there are towers along the tunnels, and the function of the towers is for ventilation of the tunnels. The tunnels are extruded in sections approximately 60, 75, or 100 feet long. Then, after the tunnels are extruded, they are lifted into the air by 3-rotor helicopter systems. It lowers it into position and then brings it in proximity of the tunnel where it automatically interlocks. In other words, there are projections that stick out that fit into the next section of the tunnel, and they're rotated. That interlocks. Here we have a section of the Trans-Sahara Tunnel with wind generators extending upward, harnessing the desert winds for generating electricity for operating the vehicles in the tunnel. I would say that possibly in the near future, the Sahara Desert can be a great source of energy due to the radiation of the sun's energy, the heat, all that sort can be used. I would say eventually all of the desert regions will be converted to some form of production center to provide energy.